am Lorch, and I'm the science teacher here at DHS. I participate in STEM 1, STEM 2, and our upper level lab science. STEM 1 and STEM 2 are integrated courses with math and English, and we do a plethora of projects, but really in STEM 1, we look at research in ecological scenarios, focusing in science on writing really valid procedures and gathering and analyzing data, while in math, they look at statistical analysis of that data and modeling and graphing it, and then communicating that to an outward audience in English. For our second project of that class, we also look specifically at a projection of into the future, otherwise kind of our sci-fi that is supported by both the English class for the writing components, the math class for those projections and models, and then the science for the content of those projections. In STEM 2, which is a sophomore class, we have more physical and chemical sciences for that, where we look at projectiles with quadratics for math, and then within Newtonian physics for science. And in our second project, we design and create our own cameras, where then we looked at not only the optics, but then the chemistry of the darkroom and a lot of triangle math, actually, specifically within that project. Collectively, they allow for students to really work on skills that will be useful for any STEM career in the future, specifically focusing on collaborating in a team, problem solving and critical thinking and authentic applications of content, communicating that to an outside audience, and making sure that their work is a professional final piece with our craftsmanship standard.
For our STEM 2 and sophomores, we start the year with our Launch into Learning projectile project, where we focus in on quadratics and modeling parabolas with various equations and graphs. They do a lot of physics, kinetic and potential energy in science, and then we build the catapults and we test them and we see who creates the best projectile. It's a super fun time. And in the spring, we actually make our own cameras. We do a lot of similar triangles, trigonometry for the different angles. They are looking at all types of different maths and sciences involved in creating their own camera. There's a lot of chemistry involved in the dark room when they go to develop their own photos. And at the end of our project, we have a working pinhole camera. Most kids do pinholes, although we have had a few who dabbled in different lenses, creating different focal lengths. And then we create our own images and have our own pictures, which is really cool and super exciting. Some of the things that we really focus on with these STEM projects, beyond just our math and science standards, for content specific, would be some success skills, so sometimes called 21st century skills. We stress and teach pretty heavily collaboration, communication, craftsmanship, general professionalism of things that you turn in. We assess those, we talk about them, we teach them, we come up with conflict resolution, which is of course helpful when you're thinking about how you're going to enter the workplace after high school. We also have really large chunks of time that we dedicate to our projects. So some days that could look like traditional math and science classes, and we just do traditional period rotations. And sometimes that looks like we might have 4 hours where we're working on any given project, which really provides a lot of structure and learning when it comes to executive functioning and how you can manage your time, whether that's over a long chunk of time or with just, in that 4 hours, what do you need to do to get done, which is much more real world when you think about life outside of high school, being given a time to work on projects.